advanced visualizations, uh, which are named Pairplot, Heatmap, and Violin Plot. Okay, so all these are the part of Seaborn library, which is an advanced library which used to uh, used to display advanced visualizations. Okay, so by the end of this lecture, we'll be able to know what these visualizations are and how to create these visualizations and how to customize these visualization according to our data and how to interpret the patterns from these distributions. Okay, so let's get started. So what is CPON? For a quick recap, it is a high-level statistical visualization library, and it is built on Matplotlib. It is used it is used whenever we require some advanced kind of visualizations to represent our data, and it also works seamlessly with pandas and best suited for exploring patterns and distribution like Matplotlib. Okay, so as you can see in the example, how do we import Seaborn library? So we can import Seaborn as SNS. It is just it means that we have given a name to the Seaborn so that we don't have to write entire Seaborn again and again in the entire code. We can just write SNS. Okay. Similarly with matplotlib.pyplot here. So our first visualization will be pair plot. So what is pair plot? So a pair plot is a visualization which shows the relationship between the numerical variables in the dataset. It is somewhat like a, as you can see in the figure, it is somewhat like a subplot in which, but here we it is subplot in which lot we can like uh, create visualizations or show relationship between the numerical visualization within a same figure. But in this pair plot, we can we don't need to like insert a figure in the axis like we did with the subplots last time. We can just give the fields that we want the relationship between, and the pair plot will directly create this type of graph which will show the relationship between each and every numerical column in a data set. Okay, so what is as you as you can see on the slide, it is useful for correlation exploration, pattern discovery, as well as data structure understanding. Okay, for example, if you want like which are the columns that are uh, showing some kind of distribution, which means having some kind of relationship between them. So you can easily figure out from the pair plot. Okay, or we can discover some kind of pattern, like what kind of distribution are we looking into, or how the numerical values are distributed uh, according to a given column. Okay, so as you can see, there is also a syntax, and we also try to work it on the code. Okay, so let's get to the code. So for that, we'll be using a hard.csv file, which is basically uh, a data set containing like various fields relating to the heart condition of a person, and try to predict in this data set, then try to predict whether the heart disease is present or not. Okay, so as you can see, we just printed the first five values of the first five records of the heart data set. So these are the types of value that we are dealing with. And here I've already created a, a different data frame of numerical values, because pair plot uh, takes the numerical values, defines the relation between uh, numerical values. So pair plot visualization, I've already run the code once. So here we will just see like what does Pairplot kind of do. Okay, so run the code, and We'll get our visualization in a second. See, so what it did is it created a distribution of every numerical column with each with itself with itself or and other columns. Okay, so you can see like there's in the leftmost left top there's a column age, and in the for that x-axis will be age. Okay, similarly we have distribution of age according to the column that is resting BP, which means resting blood pressure. It is just a normal random some file. You can also work on it on your any data you want, and then you can just create a visualization there. Okay, so as you can see, for example, we have age, and we have taking a distribution of age according to resting BP or cholesterol. These columns are also acting as a x-axis and also as a y-axis. Okay, so what we get to pair plot is a distribution relationship between each and every numerical column of the data set. Okay, so for example, it, till this part or 30, as you can see on the screen, if it's visible, let me zoom in. Yeah, as you can see, this 30 till 70, it is a age. In this range, age is represented in the y-axis. Okay, and in the x-axis, the first x-axis here is also age. So we are getting the distribution of age also according to the age, and from now downwards we have also a resting BP, which is also plotted against the age. Okay, so like this we have uh, numerical representation of every column with each other. Okay, it is sort of like visualizing the correlation. As you can see, if you remember from the previous lecture, we also deal with some kind of correlation matrix where the relationship between each column is determined. We see the uh, correlation between the each and every column. Okay, so that's how pair plot visualization look likes. Okay, now moving on, it isn't one more thing. It is an advanced kind of visualization. So it is mostly used to like see like what kind of distribution the numerical data are following with each other. Okay, so it will show you the relation between different columns in the data set. So you can like find out like what kind of columns do we require, or or uh, do we require a certain column or not. Okay, so let's move next. So pair plot customization. It is basically what like how to stylize the pair plot, or what kind of diagonal plot should be. Diagonal plots are these. Okay, as you can see these diagram, if you go to this figure, you will see that there's a diagonal here, uh, which is starting from the topmost age and ending at old peak. You are, in this diagonal, you are getting some kind of distribution graph. Okay, as you can see on the screen. Other than that, all of these are something like scatter plots. But this diagonal, you're getting a figure called KDE, which is a distribution type visualization. Okay, there are many kind of visualization. For example, if I just hover it around diagonal, you can see there's some kind of auto in which it will decide like what kind of visualization data should be, and there's also option called histogram. Okay, so instead of this distribution, we can also get the histogram. Let us try. See, now we are getting a histogram in the diagonal. Okay, earlier it was KDE. which is another kind of distribution. So diagonal kind is basically uh, defines like what kind of visualization the diagonal column will have. Okay, let's go back to KDE. And so what does this KDE means? Okay, so KDE is a kernel density estimation. It is basically a type of visual types of graph distribution which is used on the density of the future data. Okay, like as you can see, there's most of the data points would be in the middle, and it is little bit right in the second diagonal column, and it is on the left, creating two peaks. So similarly here, okay, what it does, it basically produces smooth curves rather than bars, as we saw in the histogram, to show the distribution of the data. Okay, KDE means kernel density estimation. If someone asks you like what does KDE means, so you can say it, you can tell him. Okay, so as you can see, like color separate categories, you have also some kind of color. Scatter plot shows relationship between the columns, and diagonal KD shows the distribution. Basically, what happening is diagonal is like you are uh, basically plotting one column with itself. Okay, here age, and for the age, x-axis also age. Similarly, the diagonal resting BP, this distribution, diagonal distribution, is the relationship is with itself. Okay, basically it's just for smoothing the curve so that you can like better understand like how okay this type of distribution is there. Okay, and scatter plots, you know, you have already studied scatter plots. Okay, so next visualization is heat map. Okay, so heat map is visualization relationship between using color coded representation. So as you can see, there's also already example visualization I've already pasted in the slide. Okay, so useful for correlation matrix, which means like whenever you try to find a correlation between the columns in the data set, you already know what correlation is. Otherwise, just to brush up your memory, correlation is a statistical measurement which is used to describe the relationship between the columns. Okay, and it varies through -1 to +1. uh, 0 to 1 describe the positive correlation, and 0 to -1 will describe the negative correlation. 0 being like the column does not have any kind of relationship between them. And if you have negative relationship, which means uh, the columns are negatively correlated, which means if one increases, the other one decreases. And if you have positive correlation, which means if one increases, the other one will also increase, or vice versa. Okay, so that correlation, if you want to show that correlation visually, heat map is used. Okay, so as you can see in the figure, like we have different kinds of columns and we have a correlation between each of them, each one of them. For example, that the age is related with just uh, age is related with cholesterol. The relation of age with cholesterol is -0.09, which means that on increasing age, the cholesterol is slightly decreasing. Okay, or you can say like with resting blood pressure, with increasing age, the blood pressure is also increasing since they have positive correlation of 0.25. Okay, so how do we like create this visualization? Okay, so we have this heat map coded in here, which is SNS, which means Seaborn library dot heat map, and we give it a df.core, which it will create a data which will show the correlation of a uh, correlation of a columns. Okay, we will see that in the code. So let's see. Here I've already created that, but to like what does each component do, I will show you step by step. Okay, so let me um, start. Okay, so first of all, I will show you df.core, df1.core. Okay, as you can see, it created a some kind of matrix where you can see like what kind of correlation we get from each and every column. Okay, it is a 2 by 2 matrix. Will like describe the correlation of age with resting BP, with cholesterol, fasting blood sugar, and max HR, OLP, etc. etc. Okay, so it is a metric that will pass on through the visualization called heat map, SNS dot heat map. Okay, and we will get the anode, which is a graph. Sorry, I'm saying graph, a bar which will show you the color. Okay, like at which point dark color will be there, or at which point light color will be there. Okay, let us not give it right now. Let's just give the F1 core for right now. Okay, let's see what happens. See, now this is the visualization. We have basic visualization here, and as you can see, we also got a bar with us like showing like what kind of visualization it has. Now we don't know what kind, like as you can see in the bar, we can see like at which color which value would be. Okay, but we can only estimate, not we cannot get the entire uh, exact value. Okay, so for that we will use anode equal to true. Okay, let's see now. Now as you can see, we got the exact value in the tile which was representing the correlation between the different columns. Okay, now we know what exact relationship it is. Otherwise, we would like estimate like this would be around minus 0.1 to minus 0.4 or something. Okay, so that will be anode is helpful in a way that it will show you the exact correlation between the columns. Now we will use CMap, which is basically color mapping. Like what kind of color mapping do we want? Okay, here we are using uh, we can also give some kind of string, and if we go there we can also give a list of color type. Okay, for your so that you can remember one only. Most of the time we use cool warm. Okay, warm, or there are many color mappings out there. You can just google it and look at the, if you want some kind of different color mapping. Okay, see, it is the same visualization as the given next slide. Okay, now we can easily like make out like what kind of relationship, uh, what kind of correlation with each column have with each other, as well as it is visually appealing. Okay, main point of visualization is that it should be visually appealing and should be simple to understand. Okay, so it's visually appealing and simple to understand. You can also already see like you can make out some kind of relationship even if you don't have the idea of the data. Okay, so that's a heat map, and I've already told you about like plus one me what does correlation value means, like plus one strong positive correlation, minus one strong negative correlation, and zero means no correlation. And most of the time heat map is used to use a feature selection, which means like uh, during the machine learning when we try to train your ML model, uh, the columns which are if they are very strongly positive correlated, so these are not required. I mean, if you take two columns and these are positive correlated, you can you should take only one column for training, not the both. Okay. Identify multicollinearity, which basically means like what uh, how much columns are related to each other, or like how much positive they related to each other, and understanding variable patterns, like how these columns play with each other. Okay. So let's move to next visualization. So next, or I guess the last one in this is violin plot. Okay. So violin plot shows a data distribution and statistical insights in one visual. Okay. So what does it mean is that it is used to compare the distribution of data, like uh, if you want to see like what kind of one column has a distribution with compared to other, like how does it behaving, or like the box plot we can also try to like find the outliers. Okay. And if you want to understand like is how densities uh, how the density of data is, or how much spreading across the graph it is. Okay. Basically violin plot is like box plot. Okay. So if you know box plot, you will be able to easily understand what is violin plot. Basically a distribution which is used to uh, show you the outliers or show you the spread and density of a visualization. It is basically a box plot, but with a uh, KDE included in that. So that's why you're getting this kind of spread. Okay. So let's see that in a code. Here I've already created a visualization. For example, I've taken the ST slope, which is this column, okay, with the resting BP. Okay. Those it is showing this kind of visualization where I have given the data df1 x y and so basically it is showing like how much data is distributed, what is the frequency of slow, which means that resting BP is up or down. For example, between 150 and 100, there's much more density, which shows the slope is up, as well as in the flat slope, which is basically that means that heartbeat is flat. So we have, that means there is no like, which means heartbeat is stable. That it is then between 100 and 150, and sometimes go up still more than 150, as you can see, like what kind of spread the data is having. Okay, this width, which means like most of data is uh, situated here. Most of data is between 100 and 50. Okay, so you can see in the downwards there's going some peak, like some distribution points are also beyond 150. Or you can see like in the flat that there's a line which denote the outlier. Like these are the outliers of the data. Okay, so that's a volume plot is basically to show like distribution, the spreading, or what kind of uh, basically like what is the s- most of what are the most of the points, if you or most of the values of a particular column are spreaded in a in which value, across which values. Okay, for example, if I go up flat or down, be it may 100 and 150 is the most of data is spreaded across. Okay, most of data as you can see in this spread across 100, 100 and 150. There are some outliers like as you can see in both all the like distribution, like some of are beyond 150 or some are downward below 100. Okay, so it's basically used to know what is the density of the uh, column that we want to know about. Okay, so as you can also like there's also called split violin and styling, where you can use like hue or split as you can see here. So let we will try. And what kind of interpretation that we can get these from split violin. Okay, like shape shows density as you can see here. It is a like spade shape here shows the density, like most of data is spreaded in this here. Okay, in this area or region. And represent width is represent a frequency. Okay, like how much width here is, it is a frequency, like most of the data points are here. And it is useful for comparing groups as you can see there. It it is sort of like bar chart. Okay, like it is used to describe the like some kind of categorical values, compare some categorical values of a group. Okay, so let's try with this split is equals to true. Let's see what happens. Mm. Okay, so here we just got, instead of both as we that what we were getting, yes, earlier in the visualization. Let me create another without split. Okay, so it is what you are getting. So as you can see, it is like showing the more density as compared to there, and uh, it is showing like some kind of normal distribution here. If you look at like a little bit swing or rotating your head, it is basically showing the distribution of data still. Okay, as you can see, we saw in the interpretation shape through the density. So most of the density points are here in the blue region. Okay, and the width is frequency, like it means like as you can see like distribution here, you can see the frequency also, like it is going from just below 100 till around 200. So free, and as you can see like from 200 and 200 the graph is decreasing. Okay, region is getting smaller, so that shows the frequency of point, like there are less point between 150 and 200, as compared to 100 and 150 in the all cases are flat and down. Maybe in the down part there's more, but you can see like, okay. And let's see what will happen if we palette. Palette is equal to set to, let's see what happens. Okay, so it's basically used to like separate them by color. Okay. Okay, so palette is basically for, okay, it's just the bonding. Basically like uh separating, like showing separate the category by colors also. Okay. So yeah, this is basically useful for comparing groups as you saw in the visualization. Here we have three kinds of group. Okay, like up, flat, down, which means heart. What is the heart rate? Flat heart rate. Reading them. Okay, you can also try to uh, try this visualization on your own data set so that you will get a better understanding like what these visualization are doing. Okay, so what are the key takeaways? Okay, so key takeaways, sorry, relationship between numerical values, which is described by Pairplot. Okay, heat map will be used when you need to know the correlation between the columns, and violin plot is used when you need to know about the distribution, density, and comparison. Okay, what kind of distribution and what kind of densities they have, and if you want to compare something about them, like I'm getting like in the downward slope, I'm getting more values in 150 between 200 as compared to up and flat. Okay, so that's it. And your assignment for today's lecture will be like uh, you have to create these visualizations using either Iris or Titanic dataset. You can easily find them on the net, and I mean Iris or Iris dataset again, I guess is a pre-built dataset. You can look up on the Google, and you can easily look into these datasets, and you have to create a pair plot with a hue, correlation heat map, and Violin plot comparing at least one categorical feature like we created here. As you can see, this ST slope is a categorical feature, which means uh, only the data is distributed in a few categories. Okay, so using Iris or Titanic dataset, you need to uh, create these all three visualizations and then submit your assignment. Okay, so that's it for the lecture. Thank you all.